about a definite integral. With trig. Right. So if you guys have your sheet of all your trig rules kind of out, or at least you know where that is in your notebook, it might be handy. All right. So here's our first example. Okay. So our procedure for this is going to be exactly the same thing that we've been doing, right? A definite integral, guys, I should have went over this earlier. A definite integral just means that you're bounded. Like you have a definite interval you're going over when you integrate. So here we're going from 0 to pi. It's not like just like infinity, right? So it's a definite. It's defined at a certain spot. So what we're going to do is we're going to go through and integrate here. So if you guys are going to integrate 2, what would you have to do? 2x. Good, yeah, especially because we're recording x's here. So we'd have 2x. Now, what do you guys think about the cosine?
Negative sign?
Just sign, yep. This is where your rules might help you. Okay,
Just second.
Because if you integrate cosine, it's just sign. It's like one of your rules. Yeah. Now, the last step here is we need to take our pi and 0 and actually plug them in. We're going to do the exact same thing. We're going to take pi and plug it in where you guys see it. So, take your pi and plug it in. So it looks like 2 times pi plus sine pi. Okay, we're going to do all that out. And then we're going to subtract when you put the 0 in. Make sure when you're doing things, especially involving trig functions, think about your order pairs with these spots. After 0 degree, does anybody know what your order pair is?
1, 0.
1, 0, because you're going over 1 off 0. Now pi is really like 180, so you're over here. Here's your 180. Negative 1, 0, yep. Okay.
In the last one you did on homework, didn't you add in these numerals too? I have no idea.
Oh, something, it was different because you're doing an absolute value.
Okay, so this one you're always going to subtract?
Yeah, it's like last thing was very like special.
So we got like 2 answers, so we had to add them together to get the whole.
Yeah, it's because when you're doing an area under a curve, like if I graph, so something like this, 2 plus, what was the cosec I had? I think.
Yeah.
So if I do mode, we just have to make sure we're in radian mode if we're going to graph this thing. Okay. So we'll do zoom, trig. Okay. So here's the picture you guys are working with right now. Okay, and we were going from what, like 0 to 4 or something like that? So, so 0, let's say that's 0, maybe, I don't know where 4 would be, and then, because this is all in like radians, so let's just say, I don't know, 4's here. So here, you're just taking the area under the curve to the x-axis. Now, when we were working, what you saw, like the review of is absolute value. The problem with an absolute value is it looks like something like that. So when we were doing from maybe like 0 to 4 this time, we had to take the area here and then it stopped, and then the area here. So we had to do it 2 separately. That's why it had a lot more work than we had to add it together. This will be like one step because it's not like ending or crossing anywhere. Does that kind of make sense why we have to do 2 now? Like a little bit. Absolute values, like, I think one of the hardest things in integration to do is there's so many steps involved with it. Okay. But today we won't have any kind of weird touching of anything. It just is like one integral we have to do. Okay. All right. So 2 pi. So just going to say 2 pi. Which was the sign at 180? Do you remember that? 0, but yeah.
Because it goes plus sign.
Yep, you got it. Plus 0. So 2 pi plus 0 is just 2 pi. Good. All right, now in the next part, well, 2 times 0 is going to be 0. The sign is 0. 0, good. So 0 goes 0 is 0. So if I minus 0, still just too high.
Now we'll put that at 6.28.
No, I think you leave it as too high.
So that's it? That's all
Yeah,
you do?
that's it.
Okay.
Yeah. So way easier than what we did last time. Let's do another one.
So you just give me 2.
I'll make that one.
I know, a little bit more of a pain in the butt.
Whoa.
Sorry.
You feel awkward.
I'm like, no, always you guys.
Alright, so let's integrate this. We got 2x. Now, be careful with this. We have a minus, and then, does anybody know what their
Tangent.
cotangent?
Negative.
This, yeah, it's actually going to be negative cotangent squared. Again, you guys can get that right from your, like, your note thing, okay? Or on page 272 has them all in your textbook. Okay. All right, so in here, let's clean this up a little bit. What can we make this?
2x plus cotangent squared x.
Cotangent squared x. Nice. Now we're going to integrate this thing from pi over 2 to pi over 4. Okay. I'm going to leave you guys with this part. Pi over 2 is like 90. Pi over 4, 45. You got it, Lydia. Good job. Do you need help remembering what those are?
No, in my notes, I only have cotan, not cotan squared. Did I write it down wrong?
Ooh. Sure.
I could totally wrote it down wrong.
Yeah, I was just cotan.
You have just cotan? Let me double check. Hang on, actually. Sorry, guys. Let me make sure.
Which one is the cosecant?
The other thing is negative squared.
Yeah.
What is it? Cosecant squared. Oh gosh, all right, I messed up. Negative cotan, you're right. Cosecant squared is negative. Nope, not squared here. Cotan x. Sorry about that. That's it. Oh gosh. Thanks, Kelly. Yep. Thanks, Caroline.
So instead of putting like pi over 2 times the 90,
Yes.
so we plug it in for x.
The same thing with like your pi over 4, or you can do 45 if you want. This has a lot of old math in it.
Wait, you do the top first?
Top first. Yep.
Oh my god.
But yeah, you rewrote.
Wait, what about the first?
What?
Kyle, I just asked you if we do the over 4 first and you said yes.
I meant to say no.
Oh, sorry, Kelly. Yes, it's always the top
Sorry,
one
just
first.
make the first part a negative and
Alright.
It's just cotangent, not cotangent squared.
Just cotan, yeah.
So
Sorry.
that type of one.
When you guys did your cotan of 90, what'd you guys get? 0, good. Because remember, cotan is the cosine over sine. Cotan back in the day, right? So 0 over 1 is just 0. This whole thing should just be pi. Now in here we get, this is going to be over 2, if we want to reduce it. So we have minus, and then we got pi over 2. The cotan of pi over 4 is 45 degrees. The 45-degree ordered pair is radical 2. Yep, radical 2. So if you divided the cosine by the sine, what's that just going to end up being? 1. Awesome. Okay. Now this is where a lot of you guys you can do this a couple ways. You can either distribute your negative or do this whole chunk first and then bring your negative through. If you are going to clean this up, we need to get a common denominator. Just make sure you multiply by 2. So we got over 2. Now, your minusing still this whole thing. So make sure we bring this negative through both parts. So it's like saying pi minus 2 over 2. And if we wanted to really make this nice, since it's actually a common denominator again, so 2 pi, yes, Olivia, great job. You got it, good job. So 2 pi minus 1 pi, 3 pi minus 2 over 2. And that would be your final answer.
Yeah, if you put in like 90 and...
What did you do?
That doesn't work that way.
Wait, are you using a calculator now?
No, if you put like 90 in instead of pi over 2, it comes out with you get 89 for an answer.
Oh,
Yeah,
wait.
how are you guys?
Wait, 180
I
minus
asked
2.
if I could put it.
No, it works because if you use pi
I
as 180, then
gotcha.
180 minus 2 is 178 divided by 2 is 89.
I'm sorry, I totally missed. I thought you meant like. I got you. Sorry.
That's okay.
I was thinking like, could you, when you were asking, I thought that you meant like, could you think about this like saying 45 and do it that way rather than. I got it. Oh no, I'm sorry. My bad.
Got 89 for good.
I was like, oh man.
It's still the same
When
answer.
you, it's like when you're evaluating, you have to, you could think about this part like
It is
90.
minus 2 over 2. So
Right.
It's like this.
It's actually worse in this part though, because like when you actually have pi's left, that won't be actual. You're not thinking like the trig value of that. Sorry guys, I'm not thinking what you were doing. My bad. Alright, let's do one more. Okay, so this one is tricky.
Is the answer 0?
No. No answer is 0. It has something to do with an identity. I'll give you a clue.
Oh, I got it.
I don't know the identity.
Cotangent. Cosecant squared.
Start with your one you guys know.
And that here,
Yeah.
Think about how do you get tangent? What do you have to divide it by?
0.
No, you divide by like cos.
Yes, Sarah, thank you. Good job. Someone's got to tell them what to do over here. Good work. Because if you want to get tangent, sine over cosine. Right?
So it's 1. I just want
Oh,
secant
nice
squared
math.
of
You
1.
can't.
I said secant squared.
Squared. Good job.
You
Yeah,
said
you
no.
your.
Second square.
wait, so the bottom is secant squared?
Yep.
Please excuse the
Secant squared
interruption.
over secant squared.
Would the owners of two vehicles, one a Volvo, license plate GPF6715, and another vehicle with GTX2706 report to the office immediately, or you'll be having your cars towed out of the emergency parking zone. Thank you.
You can't. Oh, we have parked in the emergency. I told her that.
What, did park go to class?
Yeah,
Yeah,
they literally park. They don't want to walk. They can't walk, but the extra 2 feet where she would actually park in a spot.
I said, what is probably the white line across her with the bus.
You're not supposed to park.
Oh, God.
If they were dotted like that.
Well, that module just recorded everything you just said. Is the microphone still?
Fine.
Hey there.
Okay. Alright, so what you guys want to start with, think about using your identity. Tan squared plus 1 is really secant squared. Now, what could you reduce this to?
1.
1. Okay, start with that.
Then what do you
There you go.
Sorry, I took
So now how do you do? Don't you do the integral?
Yep, okay, so if you integrate one, then you get the times with F.
It was so hard
And
to
now
do that
here,
they couldn't afford to do it.
Oh, so I just
yeah,
put it in.
yeah, okay. So we do the top part first. There you go, okay. Just like
Guys, I know like a lot of you guys put X's, more important for those of you going on in this. The other have like d theta, like you're dealing with thetas in here. So technically, if you were integrating like a constant, you want to use theta, not X, because you're dealing with thetas in here. Try to keep it consistent with your notation.
gotta hit it with that figure.
Alright, is everybody kind of report? Yeah, good. Alright, awesome. Okay, so your homework is on the same page in the textbook, page 293, 27 to 33 odd. Okay, should be pretty quick for you. It's not too bad. It's 4 problems.